Okay, for what we have regarding the ALEKS homework section 3.5 handout, there are some rules we have regarding properties of logarithms and what might be involved in both logarithmic and exponential equations. Again, we have the base A logarithm of a to the x is equal to x, and also where we have the exponential and the logarithmic bases to match, we have a to the base A logarithm of x is equal to x. And again, we have with our properties of logarithms, you have the base A logarithm of m times n is equal to the base A logarithm of m plus the base A logarithm of n, and vice versa. So you have this to work both ways. And for the base A logarithm of the quotient m over n, that is equal to the base A logarithm of m minus the base A logarithm of n. So division implies subtraction. And in the realm of taking the difference between logarithmic terms in the same base, we have to also to work the other way around where we have subtraction to imply division. Okay, so it's also a two-way street with this statement. And for the change of base formula, we have the base A logarithm of m is equal to the base B logarithm of m over the base B logarithm of a. And from any scientific calculator, that base B logarithm can be either the natural or the base 10 logarithm. Now, for what we have in item number 1, okay, we are looking at solving for x, whereupon we had the base 49 logarithm of x is equal to 1/2. And what I can do here is to have a logarithmic equation, and I can change the base 49 logarithm of x to just x if I take this particular property. And this will be with treating both sides of the equation as powers to which 49 is going to be raised. So we have 49 raised to the base 49 logarithm of x is equal to 49 raised to the 1/2. And let me mention, again, for wherever we have for x, we want the attachment to be a positive value. Now, we have in this outcome, so we have base 49 and the exponent raised to the base 49 logarithm of x. This will go to x, and 49 to the 1/2, that is the same as the square root of 49. So we have in this result that x is equal to 7. Now, for what we have in the second item, we have a base 4 logarithm of the quantity of 2x minus 3 is equal to 2. And whatever we have, okay, for x, we want the attachment to be a positive value. And looking at what we have now, earlier we had the base 49 logarithm of x. Now we have our single term to be a logarithmic term in base 4, and I can treat both sides as powers to which 4 is going to be raised. And treating both sides as powers to which 4 is going to be raised. Okay, so to the left, the exponential logarithmic bases cancel, leaving us with 2x minus 3. And we have 4 squared is equal to 16. And if I add 3 to both sides, okay, we have 2x is equal to 19. And we have for this end result, okay, we have x is equal to 19/2, or you can say 9.5. And 2 times 9.5 is 19, minus 3 is 16. That is positive. So x at 9.5 is valid, and x at 7 for the first problem is likewise. Okay, now in the case of what we have with item number 3, okay, and we have -4 plus the base 3 logarithm of the quantity of x plus 1 is equal to -3 And whatever we have in our solution, we want x plus 1 to be positive. Now, in the interaction, okay, we want to isolate the base 3 logarithmic term, and to do so, we can move the 4 over by adding. So we have the base 3 logarithm of x plus 1. It's going to be to the left. To the right, I have negative 3 plus 4 is 1. And again, to take care of the logarithmic base, we have applying the matching exponential base, which we have at 3. To the left, I have 3 to the base 3 logarithm of the quantity of x plus 1 is equal to 3 to the first. To the left, I now have x plus 1. To the right, I have 3. And with x plus 1 equal to 3, I have x is equal to 2. And 2 plus 1 is 3, and that is positive, so 2 is valid. Okay. Now, for what I have in the case of item number 4, I have 7 plus 2 times the natural logarithm of x is equal to 5. And for what I have here, whatever I have for x, I want x to be a positive value. And looking at what I have now, I can get the logarithmic term by itself. So if I deduct 7 from both sides, I'm down to where I have 2 times the natural logarithm of x is equal to negative 2. And here I can divide both sides of the equation by 2. And that's just to get the natural logarithm of x by itself. So the natural logarithm of x is equal to negative 1. And for what I have here, okay, now I have a natural logarithm. Natural logarithm, again, is going to be a base e logarithm. And to take care of the base e logarithm, I can apply the matching exponential base. So I have e to the base e logarithm of x is equal to e to the negative 1. E to the base e logarithm of x is going to become x. We have x is equal to e to the negative 1. And it says to round your answer to the nearest hundredth. In this case, this will be to the nearest 2 decimal places. So we have for e to the negative 1, okay, have the readout is 0.3678. And the third decimal place at 7 indicates that we have rounding up in the proximity of the nearest 2 decimal places. You have x is going to be about 0.37. Now, for what we have for question number 5, and this one we have sets of base 10 logarithmic terms. And we have the base 10 logarithm of 18 is equal to the base 10 logarithm of the quantity of x plus 2. And we have minus, okay, the base 10 logarithm of 19. And so we have 3 logarithmic terms on the same base. All these are base 10 logarithmic terms. And what I want is to have only one logarithmic term on each side. So I had the base 10 logarithm of 18 by itself, but I can condense what I have on the right. Now we have a difference of logarithms, and I can make into one statement or one term. Anything that is positive, the attachment is going to be in the numerator. Anything that is negative, we'll have the attachment in the denominator. Okay, so now we have the base 10 logarithm of 18 is equal to the base 10 logarithm of the quantity of x plus 2 over 19. And since we have the same logarithmic base, I can now set the attachments equal to each other. So I have 18 is equal to x plus 2 over 19. And if I multiply both sides by 19, So we have 19 times 18, I have 342. And we have 342 is equal to x plus 2. And we have with the proposed solution, okay, we have that x is equal to 340. And the stipulation is going to be that for whatever we have for x, that x plus 2 be positive. And I think we overwhelmingly have this to be satisfied. So we have an x at 340. 340 plus 2 is going to be 342, which is positive. So number 5 does have one solution, and that is with x equal to 340.